Astronomers just found a galaxy so far away, its light left home before atoms had even finished forming. It's called MOM-Z14. And when it was confirmed in January 2026, it broke a record that had already been broken twice in 2 years. We're looking at it as it existed just 280 million years after the Big Bang. That's not a typo. 280 million years. If the entire history of the universe were compressed into a single calendar year, this galaxy would have existed before January 3rd was even over. But here's the problem. And it's not the problem you're expecting. The problem isn't that this galaxy is far away. Telescopes have been breaking distance records for decades, and nobody panics about that. The problem is what this galaxy, and dozens like it, are doing there at all. Because according to our best model of how the universe works, they shouldn't exist yet. Not like this. Not this bright. Not this big. Not this early. And the deeper astronomers dig, the stranger it gets. Stick with me, because by the end of this you're going to understand why some of the most respected cosmologists on Earth spent 2023 through 2026 quietly asking each other a question they never expected to ask in their careers. Did we get something fundamentally wrong about how the universe began? Let's start with what MOM-Z14 actually is, because the number alone doesn't tell the story. Astronomers measure cosmic distance using something called redshift. As light travels across an expanding universe, its wavelength stretches, the same way a siren's pitch drops as an ambulance speeds away from you. The more the light has stretched, the longer it's been traveling, and the further back in time we're looking. MOM-Z14 has a redshift of 14.44. For comparison, the previous record holder, a galaxy called JWST 14-0, sat at 14.32. That tiny difference in the decimal point represents millions of years of cosmic history. Both of these galaxies existed in a period astronomers call cosmic dawn. This is the era when the first stars were igniting, when the universe was still mostly a dark, neutral fog of hydrogen gas, before starlight had punched enough holes in that fog to let the cosmos become transparent. It's the baby picture of everything, and until the James Webb Space Telescope came online, we simply couldn't see it. Hubble's mirror wasn't built to catch light this faint, this stretched, this old. JWST was engineered specifically to stare into this exact sliver of time. And when it did, it found something nobody predicted. Here's the micro-mystery inside the mystery. These early galaxies aren't just present. They're bright. Startlingly, almost unreasonably bright. One astronomer described it like walking into what you thought was a nursery and finding fully grown adults standing there instead. In 2023, a study led by astronomer Mike Boylan-Colchin looked at 6 candidate galaxies JWST had spotted, all dating to somewhere between 500 and 700 million years after the Big Bang. That's still incredibly early, only about 3 to 5% of the universe's current age. According to the standard model of cosmology, the one that's been tested and refined for decades, galaxies at that age should be small, faint, and just barely getting started, still assembling their first few clusters of stars. Instead, these 6 galaxies looked mature, structured. Some of them appeared to contain more than 10 billion times the mass of our Sun in stars alone. One researcher on the project put it bluntly: "We expected to find tiny baby galaxies. Instead, we found galaxies as mature as the Milky Way, at a point in cosmic history when the Milky Way shouldn't have existed in any form." To understand why this is such a big deal, you need to understand what the standard model actually predicts. Cosmologists use something called lambda cold dark matter, or lambda CDM for short, to model how the universe evolved from the Big Bang to today. It accounts for the expansion of space, the gravitational scaffolding built by dark matter, and the slow, gradual process by which gas collapses into stars and stars collapse into galaxies. This model has survived nearly every test thrown at it for the last 25 years. It correctly predicted the cosmic microwave background. It correctly predicted the large-scale structure of the universe. It is, by scientific standards, remarkably solid. And lambda CDM has a speed limit built into it. Star formation takes time. Gas has to cool. Clouds have to collapse. Stars have to ignite, live, and in some cases die, seeding the next generation with heavier elements. You cannot rush this process past a certain point without breaking the physics we understand. According to the model, there simply should not have been enough cosmic time, by 500 million years after the Big Bang, to build galaxies as massive as the ones JWST was photographing. So when Boylan-Colchin ran the numbers, he found that some of these galaxy candidates would have needed to convert nearly 100% of all available atoms into stars. Not the usual 10% efficiency rate we see in galaxies today. Basically all of it. Every scrap of raw material, instantly and perfectly turned into stellar mass. That's not just unlikely. Under the Standard Model, it edges toward physically impossible. This is where the headlines took off. Was the Big Bang timeline wrong? Was dark matter behaving differently than we thought? Had JWST just quietly broken cosmology? Before you get too excited or too worried, here's the twist. Because this story doesn't end where you think it does. Astronomers didn't panic. They did what astronomers actually do when the universe hands them something weird. They went looking for a boring explanation first, because boring explanations are usually right. The first suspect was measurement error. Specifically, an optical illusion caused by something hiding inside these galaxies, supermassive black holes. When gas spirals into a black hole, it heats up violently and glows, sometimes outshining the entire galaxy around it. If some of these early galaxies actually contained active, feeding black holes at their centers, that extra light could be inflating our estimate of how much stellar mass is really there. In other words, some of these objects might not be as massive as they look. They might just be more luminous than expected, for a completely different reason. The second suspect was dust, and this one is genuinely strange. Astronomers assumed the early universe would be relatively dust-free, since dust is mostly manufactured by older, dying stars, and the early universe hadn't had time to build many of those yet. But research using the ALMA telescope array found early galaxies containing far more dust than anyone expected, dust that absorbs blue and ultraviolet light and re-emits it as red light. That reddened glow can trick observation instruments into estimating a galaxy as older, more evolved, and more massive than it actually is. One team studying a galaxy that existed just 600 million years after the Big Bang found it was forming stars at an explosive rate, fast enough to explain the brightness, without needing to break any rules of physics. Just a very short, very intense burst, caught at exactly the right moment. The third suspect, and this is the one that ended up mattering most, was star formation efficiency itself. In May 2026, a team led by researcher Catherine Churosky published results that re-examined the puzzling early galaxies using improved modeling techniques and better data. Their conclusion made headlines for the opposite reason the original discovery did. There is no crisis in the Standard Model of cosmology. Once you correctly account for black hole activity juicing up the light output of some of these objects, and once you use more accurate methods to convert observed brightness into estimated mass, most of the so-called impossible galaxies stop being impossible. They're still surprising. They're still early and bright and dense with stars, but they no longer require rewriting the laws of physics to exist. So the crisis is over, right? Not quite. And this is the part most headlines conveniently leave out. Even after correcting for black holes, even after refining the dust models, even after all the math got cleaner, there is still a leftover puzzle sitting on the table. Astronomers are still finding roughly twice as many massive galaxies in the early universe as the Standard Model predicts. Not 10 times too many. Not 100 times too many, like the original panic suggested, but twice as many, a factor of 2, stubbornly refusing to disappear no matter how carefully the data gets reprocessed. That's not a crisis. But it's not nothing either. It's a gap. A real, measured, repeatedly confirmed gap between what Lambda CDM predicts and what JWST keeps photographing. And the leading explanation right now is almost more interesting than a broken universe would have been. Some researchers think the early universe was simply better at making stars than the universe is today. Picture cosmic star formation like a factory. Today's factory runs at maybe 10% efficiency. Most of the raw material, the gas, gets blown away by stellar winds, supernova explosions, and radiation pressure before it ever collapses into a star. But in the extremely early universe, before galaxies had built up strong magnetic fields, before multiple generations of supernovae had enriched and disrupted the gas clouds, that inefficiency might not have existed yet. Gas may have collapsed into stars faster, cleaner, with less material escaping the process. A younger, hungrier factory, running with almost no waste. If that's true, it means the earliest chapter of the universe's history ran on different rules than the chapters that followed. Not broken laws of physics, different initial conditions. A universe that started out unusually efficient at building itself, before eventually settling into the slower, messier pace of star formation we observe in galaxies today, including our own. Which brings us back to MOM-SAW 14, sitting out there at redshift 14.44, 280 million years after the Big Bang, patiently existing as a genuine outlier, even inside a dataset already full of outliers. Lead researcher Rohan Naidu described the discovery with a phrase that's stuck with astronomers ever since. With Webb, we are able to see farther than humans ever have before, and it looks nothing like what we predicted. His co-author on the study put it even more directly. There's a growing chasm between theory and observation related to the early universe. A growing chasm doesn't mean the theory is wrong. It means the theory is incomplete. And incomplete is a very different problem than broken. Every major leap in our understanding of the cosmos, from Hubble discovering the universe was expanding, to the discovery of dark energy in the 1990s, started with exactly this kind of small, stubborn gap between prediction and observation. A gap nobody could quite explain away, until eventually somebody did, and in doing so, rewrote part of the textbook. We may be watching that process happen again, in real time, one JWST image at a time. Here's what makes this genuinely unsettling if you sit with it for a second. Every single galaxy we've talked about in this video, MOM-Z14, JWST-14-0, the 6 massive candidates from Boylan-Colchan's original 2023 study, they aren't rare freak discoveries anymore. JWST keeps finding more of them, in nearly every deep-fielded images. What started as one weird anomaly has become a pattern, and patterns in astronomy don't go away quietly. They demand an explanation, and right now, we only have partial ones. Black holes explain some of the light. Dust explains some of the mass overestimate. Faster early star formation explains most of what's left. But most is not all, and that leftover factor of 2 is still sitting there, unresolved, in paper after paper, survey after survey. JWST isn't finished either. Astronomers are now pushing into mid-infrared observations and deeper spectroscopy specifically to pin down, once and for all, exactly how massive these earliest galaxies really are, and exactly how they built themselves so fast. Researchers studying this have said openly that within the next decade, we should finally know whether this oddity gets fully explained within the existing model, or whether it's the first real crack in a framework that has otherwise held up for a quarter of a century. So the next time someone tells you we basically understand how the universe began, remember MOM-Z14. Remember a galaxy sitting at the very edge of observable time, existing when the cosmos was less than 2% of its current age, glowing with a brightness that still doesn't fully add up. We're not looking at a broken universe. We're looking at the limits of our own models, being tested by the sharpest telescope humanity has ever built, one impossible-looking galaxy at a time. And somewhere out past MOM-Z14, hidden in light that hasn't reached us yet, there are almost certainly galaxies even older, even stranger, still waiting to break the next record and raise the next question we don't yet know how to ask.